Thanks for joining us on this, our final installment of our webinar series here at the National Museum of the Pacific War in paying tribute to the 75th anniversary of the end of World War II. I'm Jeff Copsetta, and I'm joined by three panelists today. We're joined by the Director of Education at the National Atomic Testing Museum in Las Vegas, Mr. Joe Kent. We're joined by our very own archivist here at the National Museum of the Pacific War, Chris McDougal, and our Director of Education as well at this museum, Dr. David Shields. And they're here to talk to you today about a topic that's at times very difficult to talk about. And that is, of course, the decisions to drop the atom bombs on the cities of Hiroshima and Nagasaki during World War II, forcing the Japanese to sign the Instrument of Unconditional Surrender in Tokyo Bay on 2 September 1945, essentially ending World War II. So here to give us a presentation on one of our very unique and rare artifacts that we have here in the George Bush Gallery is Dr. David Shields.
Hi, everybody. Very nice to meet all of you. And I wanted to just take a brief moment to let you know what we do here at this museum to interpret and show a very important resource concerning the end of the war. As you go through our museum, you come to the very end, you will actually see a casing of Fat Man. And what I want to do is show you a brief little video of what we have, so that might make sense to you. Our focus here at the museum is on Fat Man, which was the second bomb dropped on Nagasaki about 3 days after the bomb dropped on Hiroshima, when the Japanese refused to surrender. There was a difference between Little Boy, dropped over Hiroshima. Little Boy used at its core uranium-235 and had a blast yield of about 15 kilotons of TNT. Fat Man, on the other hand, used plutonium as its core and had a blast yield of 21 kilotons. However, both bombs flew from Tinian on B-29 Super Fortress. Of course, everyone knows the very famous one, Enola Gay, which was flown by Colonel Tibbets, but both planes had the same operational ceiling of 31,000 feet, flying at about 200 miles per hour. But Major Sweeney, who flew Boxcar, was the B-29 that left Tinian on August the 9th, originally for a city called Kokura. A lot of people don't know that, but when the plane reached IP, which is known as the initial point, Major Sweeney and his crew realized that the target was obscured by rolling in clouds and also conventional bombing raid smoke, which had occurred earlier in the day. So after attempting to fly around Kokura, they realized that they would be impossible to hit their target on specifically how they wanted to. They also encountered the situation that they were running low on fuel. So they headed about 30 minutes to their second target, which was Nagasaki. At 11:01, a $25 million bomb, the Fat Man, was dropped on Nagasaki. Ultimately, when you take into account radiation, nearly 80,000 people died in that attack. And in the end, Boxcar barely made it to Okinawa with its second engine of 4 stalling out because of a lack of fuel. So pretty exciting event. And there are a number of issues concerning Boxcar even leaving. It had mechanical problems. But for us, we definitely show a demonstration of the images of the aftermath of the bombing. But our casing is quite important. And a lot of people think, when you consider the idea of a third shot, that had the decision to continue dropping bombs on Japan been made by the president, the casing you see in our museum could very well have been that third or fourth bomb dropped on a Japanese city. So pretty dramatic stuff there. Now, at this point, I think I'd like to turn it over to Joe Kent, who is in Las Vegas. So let me just end here and let you go back to you, Joe. Thank you.
Thank you, David, and thank you, Joe, for joining us. What do you have there at the National Atomic Testing Museum out in Vegas? What do you have to show us today, Joe?
First off, thank you so much for having me today. It's a pleasure to be here. Greetings from Las Vegas. So I'm at the National Atomic Testing Museum, and this behind me is our brand new Trinity Exhibit. Here we talk about the beginning phases of the Manhattan Project all the way up through to the dropping of the weapons on Hiroshima and Nagasaki. Behind me is Gadget. It's a model of the device that was tested at Trinity. We'll talk a little bit about that later in my presentation, but that is an actual model to scale. So it is a large device, very similar to the device that was used in the Fat Man weapon. So World War II and the fear of a German atomic bomb is what spurred President Franklin Roosevelt to authorize the Office of Scientific Research and Development and the Army Corps of Engineers to launch the Manhattan Project in 1942. The reason for Roosevelt's decision could be traced back to three key moments: the Einstein-Szilard letter being sent to the president, the Maud Committee report, and Japan's attack on Pearl Harbor. In 1939, physicist Leo Szilard was one of many scientists concerned about the recent discovery of nuclear fission by German scientists Otto Hahn and Fritz Strassmann. These scientists feared that Nazi Germany would use uranium being mined by the Belgians to develop a fission bomb. Szilard met with fellow Hungarian physicists Albert Einstein, Eugene Wigner, and Edward Teller to draft a letter warning President Roosevelt about the possible threat posed by the Germans. Szilard wrote the letter, and Einstein edited, signed, and forwarded it to the president. The Einstein-Szilard letter urged President Roosevelt to start a nuclear testing program, it was Britain's Maud Committee that really convinced him to put it into high gear in about October-November of 1941. The committee finally proved an atomic bomb was a realistic invention in the sense that a reasonable amount of enriched uranium-235 could be made from uranium-238 to make a nuclear chain reaction. Scientists initially feared that it would take tons more uranium to accomplish this goal. Now, a little over 2 years after the Einstein-Szilard letter was sent, and mere months after Roosevelt learned about the Maud Committee findings, Japanese aircraft appeared over the US naval base at Pearl Harbor in Oahu Island, Hawaii, in the early morning of December 7th, 1941. During the overwhelming assault that followed, over 3,000 Americans were wounded or killed, including civilians and military personnel, and over 180 aircraft were destroyed. President Roosevelt called December 7th, 1941, the date which will live in infamy. The next day, Congress issued a declaration of war against Japan and joined World War II on the side of the Allied powers. Now, while only $6,000 was initially authorized to work on the Manhattan Project, the cost of the program eventually grew to be over $2 billion by the end of the war. The project was made up of sprawling, isolated facilities all across the country, each with their own specific objectives. The Met Lab was established underneath the University of Chicago's Stagg Field to find a viable way to make plutonium. Chicago Pile 1, the original nuclear reactor, was built on the remains of an old squash court under the Stagg Field. On December 2nd, 1942, scientists initiated the very first sustained and controlled nuclear chain reaction, a major breakthrough that proved plutonium production was possible. In 1943, Los Alamos Laboratory was developed in New Mexico as a Site Y of the Manhattan Project. Nation's leading scientists were recruited to uncover the secrets of nuclear fuel. In addition to learning how this fuel behaved, the scientists had to determine how much would be needed and how the bomb would be shaped and assembled. The scientists managed to design and manufacture 3 atomic bombs in just 27 months. Now in rural Oak Ridge, Tennessee, more than 80,000 workers built and operated huge plants in 1943. They built and operated plants designed to separate uranium-235. It included Y12 electromagnetic separation plant and the X10 graphite reactor. The facilities produced 64 kilograms of refined uranium, just about enough to fill a shoebox. They repeated a process to do this called gaseous diffusion. Engineers actually needed to develop a way to store the nuclear material to avoid an accidental explosion. Now, Clinton Engineer Works provided the uranium necessary for the little boy atomic bomb that would come later. One scientist at the Met Lab that we talked about earlier demonstrated that plutonium could be created in a reactor, work began on a full-scale plutonium production facility. Workers constructed Hanford Engineer Works along the Columbia River in eastern Washington in order to produce large quantities of plutonium-239. Now, during the summer of 1943, the town of Hanford became a true boom town, employing over 40,000 people. Hanford Engineer Works would go on to supply the plutonium required for Gadget and Fat Man atomic bombs. The Manhattan Project provided roads, housing, food, and infrastructure for an essential workforce of over 500,000 men and women. Such a massive undertaking required strong leadership and a group of arguably the brightest minds ever assembled. Brigadier General Leslie Groves, later promoted to Lieutenant General, was selected to oversee this top secret project in 1942. From 1940 to 1942, Groves was the Deputy Chief of Army Corps of Engineers and oversaw all Army construction in the United States. This included supervising the construction of the Pentagon, which was the headquarters of the Department of War and later Department of Defense. He hired J. Robert Oppenheimer for the program as the director of Los Alamos Laboratory. He was teaching theoretical physics at the University of California, Berkeley when Groves reached out to him. He ended up recruiting the nation's top scientists for the Manhattan Project, focusing on those already doing atomic research at universities across the country, such as those located in California and in New York. Enrico Fermi, his research led to the first industrial size B reactor at the Hanford site in eastern Washington that we talked about. He had previously directed the Met Lab's groundbreaking nuclear chain reaction. He later became the associate director of Los Alamos Laboratory. Oppenheimer enlisted Ernest Lawrence for the Manhattan Project while he was a physics professor at the University of California, Berkeley, and the director of the school's radiation laboratory. Lawrence developed the cyclotron, which accelerates nuclear particles at very high speeds. And he also created the electromagnetic isotope separation process at Oak Ridge's Y12 plant in Tennessee. Now, Hans Bethe escaped from Nazi-controlled Germany in 1933, and he began teaching at Cornell University about 2 years later. Oppenheimer recruited him to lead the theoretical division at Los Alamos Laboratory. Bethe's team studied how neutrons move in critical and subcritical masses and how liquids and gases behave at incredibly high temperatures. They also calculated the efficiency of a nuclear explosion, ensuring that the bomb would not ignite the Earth's atmosphere, which was a concern at the time. Joseph Kennedy led the chemistry and metallurgy division at Los Alamos. His department worked on the purification of plutonium, a difficult problem that plagued the project. Kennedy also spearheaded the fabrication of uranium and plutonium metals for the project. Emilio Segri's P5 group at Los Alamos measured the radioactivity of various fission products. He discovered that plutonium would spontaneously fission inside the gun-type assembly, which necessitated the development of an implosion-type bomb. Piece by piece, scientists assembled the atomic puzzle and soon found immense potential hidden inside. As discovered in 1911 by Ernest Rutherford, atoms are made up of electrons orbiting a proton and neutron core. In 1938, as we discussed earlier, German chemists Otto Hahn and Fritz Strassmann used neutrons to split uranium atoms, causing release of energy. Jewish physicist Lisa Meitner and her nephew Otto Frisch, also a physicist, confirmed this reaction as nuclear fission. Scientists reasoned that if splitting a single atom produces energy, then splitting many atoms would lead to lots of energy. In a nuclear chain reaction, each atom has to split in at least two others, increasing the size of the chain reaction very quickly. Now, going on to the types of methods, we had already talked about the gun type, or introduced the topic of the gun type. But what that means is that it was a design for little boy, and refined uranium was used that was actually produced at the Clinton Engineer Works in Tennessee. Now, this mechanism shot one subcritical bullet-shaped piece of uranium into another piece of uranium to form a supercritical mass. On the other side, you have the plutonium implosion weapon. The implosion method, on the other hand, used plutonium created by Hanford Engineer Works in Washington, and it was featured in both Gadget and Fat Man. A TNT shell made of a series of explosive lenses was designed to explode around the plutonium core. The lenses exploded inward, and they compressed the core until it reached supercriticality. And that was coming from Emilio Segri's talk about how plutonium was just too explosive and too unstable to be able to be done through the gun type model. And here's just some images I wanted to share with you. So talking about the nuclear fission, you can actually see below how that looks. You have the neutron hitting the uranium-235 atom, which then splits, 2 neutrons are released, then break up more uranium atoms. And that chain reaction releases energy every single time that happens, leading to the final explosion that you're familiar with. Now, here's some images of the gun type and implosion assembly methods. You can see that the gun type is exactly how it sounds. You have the conventional, or you have the uranium mass being shot at a subcritical piece of uranium-235. And once those collide, that's what creates the explosion. And then here is the implosion assembly method. You can see how in the image you have explosions going all around it, eventually compressing that core. Now we go on to Trinity, the very first atomic test. Now, just before sunrise on July 16th, 1945, after 2 years of intense work, scientists scorched the Jornada del Muerto desert in New Mexico. Located at a remote corner on the Alamogordo bombing range, the site was 120 miles south of Albuquerque, New Mexico. Trinity, named after a poem written by John Donne, was the world's first nuclear weapons test. Tensions were high leading up to Trinity, as President Truman's strategy to force Japanese surrender hinged on the success of this test. Failure was not an option. Yet many were uncertain that everything would go according to plan. As we talked about earlier, this is Gadget. While the test was called Trinity, the device itself was nicknamed Gadget and was an implosion-type weapon identical to Fat Man. Now, detonated atop a 100-foot steel tower, Gadget had a yield of between 19 and 22 kilotons, or roughly 19,000 and 22,000 tons of TNT, respectively. So that's how we measure the yields here at the museum. We talk about 19 kilotons, 21 kilotons. What that means, like I said, is equivalent to thousands of tons of TNT. Now, eventually they would test weapons that were megatons or millions of tons of TNT as they tested more and more. Now, Gadget was exploded just as is atop that tower. Batman had a similar device inside of it. So where it was dropped from Boxcar, this was actually inside of the shell that you saw earlier. Now, after Trinity was deemed a success, workers found that they were later found what they coined Trinitite. Trinitite is a unique substance created by nuclear blasts, formed when soil is superheated by the thermal energy released from a nuclear device, and it fuses into a glass-like material. And every year, we're noticing there are less and less people around that have witnessed what an atmospheric detonation of an atomic bomb is like. And I'd like to share a first-person account of such an event from 1952. About 200 reporters were invited to view a 31 kiloton test from the Nevada Test Site's news knob. John Kerrigan, aka Wes Peterson, wrote about his experience shortly after. This is his quote: "You put on the dark goggles, turn your head, and wait for the signal. Now the bomb has been dropped. You wait the prescribed time, then turn your head and look. A fantastically bright cloud is climbing upward like a huge umbrella. The rest is anticlimax. You brace yourself against the shock wave that follows an atomic explosion. The heat wave comes first, then the shock, strong enough to knock an unprepared man down. Then after what seems like hours, the man-made sunburst fades away." And we've heard similar accounts from our volunteers, a lot of whom have actually worked at the site, and people who have come in to go through the museum who have worked out there as well, have all shared a similar experience. How they see that initial flash that's brighter than the sun, the formation of a mushroom cloud, the shock wave rushing at them. And we've even heard some people who have been knocked off their their feet because of it. Now, onto the dropping of the atomic bomb itself. Now, the target selection list was finalized on July 25th, 1945. Leading up to August, the interim and target committees finalized the list of the atomic bomb targets. These are Hiroshima, Kokura, Nagata, and Nagasaki. Kyoto was a cultural center in the former capital of Japan. It had been the top of the targets committee list back in May. Though it was valued for its possible psychological impact on the Japanese people, Kyoto was removed at the behest of Secretary of War Henry Stimson. According to the notes of the May 10th and 11th Target Committee meetings, Hiroshima was deemed an important army depot and port in the middle of an urban industrial area. Those in attendance made special mention of the hills adjacent to the city, which they thought could produce a focusing effect and increase the damage caused by the weapon. Kokura was elevated as a target due to it being home to one of the largest arsenals in Japan. But due to poor visibility, as David mentioned earlier, Nagasaki was spared, and Nagasaki was selected as a last-minute replacement. And it was because it was only about 95 miles south of Kokura. The U.S. began shipping the components of these weapons to Tinian in the Northern Mariana Islands. Tinian would be the launching point for the atomic bomb attacks against Japan. Work began on the assembly of Little Boy once the last pieces arrived on July 29th. On August 4th, 2 days after the U.S. began assembling the Fat Man device on Tinian, Lieutenant Colonel Paul Tibbets briefed the 509th Composite Group, the unit tasked with deploying nuclear weapons, ahead of the planned strike. All they had been told is that it was an extremely powerful weapon, but they didn't know to what extent the weapon was going to look like. Tibbets and Enola Gay delivered the first bomb, while Boxcar, piloted by Major Charles Sweeney, delivered the second. So here are some photos. That's the runway in Tinian. You have the side of Boxcar, the plane that would, aircraft that would drop Fat Man. And then you have Little Boy being assembled out at Tinian. Now, Trinity and the bombs dropped on Hiroshima and Nagasaki were not the last the U.S. Used nuclear weapons. They would go on to detonate the first post-war series of nuclear tests called Operation Crossroads, which was conducted in the summer of 1946 near Bikini Atoll in the Marshall Islands. Crossroads involved the detonation of 2 Fat Man-style nuclear weapons on a fleet of old but very historic surplus ships. These included the legendary battleship USS Nevada, the Japanese Pearl Harbor flagship Nagato, and the first of the true heavy aircraft carrier US Saratoga. On August 1st, 1946, President Truman confirmed the civilian control of atomic energy by signing into existence the Atomic Energy Commission. Between 1946 and 1958, the U.S. carried out 105 nuclear tests at the Pacific Proving Grounds. Now, the Nevada test site is located 65 miles northwest of Las Vegas. And from 1951 to 1992, the site grew from 680 square miles to 1,375 square miles, and was home to 100 above ground and 828 underground tests. It was created as a primary continental testing site as concerns grew about the cost and security of testing in the Pacific near the Marshall Islands, including the Bear Reactor Experiment Nevada or the Bren Tower Project, which helped gather medical information for the survivors of Hiroshima and Nagasaki. Now known as the Nevada National Security Site, the site focuses on a broad range of programs, such as stockpile stewardship and the first responder training. Thank you, and I'll hand it back over to Jeff. Thank you all for listening.
Let's hand it over to Chris now and talk about some of the possible scenarios had we not dropped the atomic bombs to end World War II. So Chris, take it away.
To begin with, let's start with what I'm going to cover here. I'm going to talk about the Potsdam Conference, U.S. plans, the atomic bombs, and surrender. Okay, the Potsdam Conference. After the Yalta Conference of February 1945, the Big Three, Stalin, Churchill, and US President Franklin D. Roosevelt, agreed that they should meet after the surrender of Germany to determine what post-war Europe would look like. Germany surrendered the following May, so a decision was made to meet the following July at Potsdam, Germany. A primary reason to meet was to discuss the defeat of Japan. During the lead up to this conference, it was thought that the entry of a neutral Russia into the fight and a planned US invasion of Japan would be the most likely way the end of the war would come. Leading up to the conference, President Truman did not have a lot of faith in the atomic bomb. That changed the day before the conference began with the success of Trinity. With the results of Trinity known to Truman, he must have felt like he did not need to depend on Russia to help end the war, and when the Potsdam Declaration was made on July 26, it stated that only unconditional surrender would be accepted from Japan. Here are some considerations about the closing months of the Pacific War before the atomic bombs were used. At this point, the Imperial Japanese Navy had been devastated, and that made it possible for the US and British navies to blockade and bombard the home islands at will. This, combined with missions flown over targets in Japan by carrier-based aircraft and B-29s from the Marianas, strangled the Japanese economy. Psychological warfare was also employed. Leaflet bombs were dropped over Japan with the hope that turmoil and doubt would be created and undermine the will of the Japanese people to die for Emperor Hirohito. Two examples of leaflets are shown here. One is similar to a newspaper and was used shortly after the first atomic bomb was dropped. Notice a photo of the bombing in the leaflet on the left, upper left there. And the other refers to area bombings. It is not known how effective this effort was, but the point I'm trying to make is that before the atomic bomb was used, there was some thought given to weakening the will to resist the US invasion. The number of estimated casualties for the invasion of Japan were in the hundreds of thousands, and as I'm about to discuss, it was expected to last many months into 1946. The two images there on the bottom of the slide indicate what contributed to those high casualty figures. The photo on the right shows part of the damage sustained by USS Aaron Ward off Okinawa during multiple kamikaze attacks. And the photo on the left shows hundreds of grave markers in the 96th Division Cemetery on Okinawa. Altogether, the US lost more than 49,000 men at Okinawa, both killed and wounded. And there were more than 76,000 killed on the Japanese side. In short, invasion of Japan was expected to be extremely bloody. Operation Downfall. Planning for the invasion of Japan's home islands began in earnest during early 1945 by the US Joint Chiefs of Staff, and the overarching codename of Operation Downfall was given to it. As seen here, there were two parts to the plan. The first part was called Operation Olympic and was scheduled to begin around November 1 in 1945, and it would take place at the island of Kyushu. The second part was called Operation Coronet, and it was estimated to begin on March 1 of 1946 and would take place on the island of Honshu. The planning of both operations took into account the difficult terrain of Japan. Landing beaches were scarce, and only the first part of Downfall at Kyushu was suitable for that. Air bases would then be established on that island, and that would help the assault on Honshu, which was planned to begin in Tokyo Bay. The figures for Downfall are staggering. More than 750,000 US servicemen were expected to be devoted to Olympic on the ground, and more than 1 million were expected to be devoted to Coronet. 14 divisions were to land at Kyushu, and 25 were to take part in the campaign at Honshu. To counter this invasion, the Japanese were prepared with their own plan, codenamed Ketsugo, meaning decisive. Japan's military planners were aware that Kyushu would present the most likely place for the U.S. to begin their campaign, and preparations started in earnest during June 1945, when it became obvious that Okinawa would be lost. The atomic bombs. I'm going to cover this very lightly because Joe and David have pretty much already covered them. And but all I can add are the dates and what they were called. The first bomb to be dropped was Little Boy, and that was at Hiroshima on August 2nd. The second bomb was called Fat Man and was dropped on Nagasaki on August 9th. Now, I would like to go on to one of the great strengths that we have here at our archives. We have a wonderful collection of firsthand accounts of the war. Veterans who were there have provided us with oral histories, memoirs, symposium testimonials, original diaries, and original letters. It is a very rich and remarkable amount of material that we have been accumulating for close to 50 years. A couple of examples from that material are what I want to talk about next. Tomokazu Kasai was a fighter pilot in the Imperial Japanese Navy and appeared at our annual symposium in 2004. He was credited with 10 victories while serving near Guam, Peleliu, and the Philippines. On August 9, 1945, Kasai was assigned to the 343rd Naval Air Group at Omura Air Base. He stated that he had gone up into the nearby hills with a group of pilots to exercise that day and was about 25 miles from Nagasaki when the atomic bomb detonated. In describing what he experienced, he said, "There appeared the mushroom cloud just above the hill, and in 20 minutes or so, we felt the bomb blast. We were all surprised that the bomb blast arrived. What a deadly bomb." Another witness to the destruction of that same bomb was John Wesley Isaac, who served on the destroyer USS Murphy during the war. 2 months after the second atomic bomb was dropped, and almost 3 weeks after the surrender of Japan, Isaac visited Nagasaki and then wrote a letter home to a former high school classmate. In describing what he saw, he stated, "Honestly, Margie, it's impossible to realize the damage wrought by one of these bombs. For an area of about 8 or 9 square miles, everything was completely leveled to the ground. Even the steel beams used in the factories were shattered into segments no larger than a foot square. By standing on one side of town, I could look straight across to the hills without so much as a pole standing to obstruct my view. A mountain approximately 3 miles from the explosion was seared by the blast, and all the vegetation on it was burnt as by a forest fire." The next topic I'm going to talk about is the surrender. The ending of the war appeared imminent to many by the time the second atomic bomb was dropped. Even so, there was no way to be exactly sure when the end would come, and many might have thought invasion would still be needed. That is why the celebration at the end was so enthusiastic, and as I have indicated with the slide, such a lengthy one. In short order, starting on August 10 and ending August 14, Japan first offered a surrender, which included a request that the emperor remain as sovereign. That was rejected by President Truman because, as the Potsdam Declaration stipulated, an unconditional surrender was required. The offer of unconditional surrender was then offered and accepted, and that announcement was made to the world on August 14. Planning for the official surrender began after General MacArthur met with Japanese representatives on August 19, and as we all know, the formal surrender occurred on September 2 at Tokyo Bay, Japan on USS Missouri, as seen there on the photo on the right. The photo on the left shows the reaction at the Omori POW camp near Tokyo during mid-August after the final peace was announced. During that time frame, a lot of words about the end of the war were penned by excited service members stationed throughout the Pacific who had previously been preparing for the invasion of Japan. I'm going to conclude my presentation with a couple of examples from our archives. The first example comes from Charles Howard Adams, who commanded Kazu 52 on Iwo Jima. In a letter to his wife on August 11, he began with, "Ah me, there comes a day when even the lowliest of men comes into their own, and we are all hoping that morrow be the day." As you now know, Japan has sued for peace on condition that they keep their emperor. And while we think the Allies will turn down any string to the surrender, it forecast an early termination of the war. Now, we are all wondering just how much longer we will rust out here, waiting instructions to start rolling up the camp. I'm going to conclude with the ending of a letter typed by a sailor named Gus Stewart to his wife. The thoughts that Gus concluded with, I think, sums up what was on the minds of a lot of service members at the time. He wrote, "So here I sit, hoping that the next few days will see the end of the war, and wondering how long it will be before I'll be sitting across that dinner table from you and regaling you with exaggerated stories about how I won the war in the Pacific with a typewriter. Much as I hate, I think I'll always be glad I was in it. There are a lot of things I don't think I'll ever just take for granted again." And with that, I take it back to Jeff.
Thank you, Chris. That was a wonderful sentiment there at the very end. Folks, for those of you who are participating, make sure that you use the chat feature to go ahead and type us a few of your questions, and we'll get to as many as we can in the time allotted. In the meantime, as those questions are coming in, I'd like to turn it back over to all three panelists. Typically at the end of our webinar session, we just kind of open it up to the three of you. If there's any discussions internally that you guys would like to discuss amongst yourselves, we'd surely like to listen in on that as those questions were coming in. So I'll open it to the three of you now, whoever would like to go first. And once again, thank you to all three of our panels for participating today.
Well, I would just say one thing that I think Chris and Joe could probably respond, and I think maybe some people might ask. Chris had mentioned that they weren't sure that all of the fine details would be taken care of in terms of the surrender, and that the thought was that war would continue. One of the things I perhaps was a little too brief in mentioning when I was showing you the video of Fat Man in our or the Fat Man 2 that we had in our museum, was this term called the third shot. And the third shot was the idea of a third bomb being dropped sometime between August the 11th and August the 9th. And that's where our particular bomb casing fits in, because that could have been used. And the concern was, if Japan did not surrender, would a third bomb been dropped? Would a fourth bomb been dropped? And most leading information indicates that that probability was still on the table. As for that second Fat Man, President Truman explicitly said, "Do not drop any more bombs after Nagasaki without my approval." The whole idea of dropping these bombs, as Joe also mentioned, was to create a psychological effect. Well, that psychological effect happened on our side as well. So I just thought I'd mention that too, because a lot of people were interested. Was the only option those two bombs or invasion, or were there other bombs? We don't know for sure what would have happened, but there was further bombs as an option.
The other two, you guys have anything to add to that as well on that third shot? I think that's answering a few of our questions as they're coming in as to what exactly was the plan. There were 72 hours between those two, and what were, had the initial surrender not come through, what exactly the plan was. Joe, do you have anything to add to that third shot?
Yes, absolutely. I'm just checking my notes real quick on that. I know that they were talking about having, of course, like David was saying, somewhere between the 11th towards, the 17th, 19th of August, they were looking at that. They were also looking even beyond that if they needed to have more atomic bombs ready. They were looking to September and October and November, December. And by December, they planned on having several ready to go in the arsenal if it needed to come to that. So Groves had been keeping Truman up to date on the production and how that was going. And so even when Truman was looking to possible surrender, he was still getting an information about what might actually be ready to go if it needed.
Well, we're getting quite a few questions coming in. We're going to try to hit some of these, like I said, as much as possible. Joe, this is to all panelists, but you may be able to answer this one a little bit better as far as the design. What was the importance of having two separate bomb designs? What was the significance of it using two completely different types of bombs?
Well, that's a great question. So what it came down to is that it was much harder, and we talked about this a little bit in my presentation, where it doing all of that work on the uranium, refining it, only gave them about a shoebox full of uranium. So it was much harder to produce the uranium than it was to create that plutonium. So the plutonium bomb was it was easier to manufacture that. And so because of that, and talking about Emilio Segri, how he realized that gun type, it was too unstable, and so it actually be volatile and would not and could be unpredictable in that way. So that necessitated the other design, because I knew they needed to use the plutonium in order to produce enough weapons. So most of the weapons afterwards really looked at the plutonium design, because the uranium designs and producing uranium itself, it just wasn't or refining uranium, I should say, just wasn't as easy, because plutonium is almost all plutonium is man-made. So the weapon, in the weapons that they use, nearly all plutonium is man-made. And because of that, it's just easier to produce than trying refining uranium that they find. So that was the big reason for the difference. Excellent.
So another question we have here is a widely accepted casualty projection was over 1 million. That's a broad projection. So are we including U.S., Japanese? Are we including military, civilian? Is that a total number of casualties? And I'm assuming, of course, that they're talking about had we had to go implement Operation Downfall, what those casualties would be like.
Well, I think the numbers that I have here in our museum indicate on the U.S. side around 435,000, including both Olympic and Cornet, the entire attack. And Cornet was going to be much, much larger than Olympic. Olympic was the first assault, as Chris mentioned, and the Cornet was going to sweep everybody out of Europe several months later to do the second attack, and that was going to have the much larger casualties. But of course, those numbers were all based on projections of Japanese resistance, and later more information seems to have been revealed or reveals itself to indicate that the Japanese had more than we initially thought. So they had more planes in reserves. They had other means that they were going to use to fight. So those numbers may very well have been conservative.
Is there still any remnants of any after effects that are still being felt or seen in those two cities?
Well, I don't know. I think Joe might have some information on that. I was in Hiroshima last year. I went with a group of students here that the museum organized. And let's see. I didn't know Hiroshima. I went there 2 years ago. And of course, it's completely safe. There's no no-go areas. You can actually go across the bridge. I think it's a T bridge, which was used as the target of dropping the bomb. And surely it's a new bridge, but the bridge is there. There's no contamination with the water. But I don't know if there is any other residual issues that I'm not aware of. But in terms of a healthy population, it is a very busy, vibrant city. So it doesn't appear to have any residual fallout.
Yeah, and that's one thing that I feel, we recently had a webinar with a survivor of Hiroshima, and that was through us working with the Hiroshima Peace Memorial Museum. And one thing that we talked about with them prior to the talk was that, that image of a destroyed Hiroshima and Nagasaki is burned into people's brains. But it recovered, and it's, not that it discounts, of course, what happened, but they have recovered. And I can't speak about, how much residual that they have or anything like that, but I can say that at a place like the Nevada test site, which is one of the things that we talk about heavily here, being in Las Vegas, there were 928 total nuclear weapons that were tested out in the Nevada desert. 100 of those were atmospheric. And there are still public tours that go out there. There are some areas that are restricted, but typically, it's, at least at the site, most areas are safe. Typically, you have the stuff that lasts the longest is going to be alpha radiation, which is only dangerous if you ingest it. But if you have the right gear, you're fine. Now, gamma, which is, the most, dangerous, that only lasts a shorter time. So if there's elevated levels, they're not dangerous levels, is what I'm saying. So now that's not to say that there haven't been issues in the past, of course, with people having illnesses because of the radiation that of course happened at the site as well. Downwinders is something that we talk about here at the museum. Testing out of the Nevada desert, that radiation had to go somewhere from those atmospheric tests. And St. George, Utah is one of the examples that we speak about. And there are compensation, there's compensation in place for survivors who had negative health effects because of the radiation. So there's certainly still residual effects, and people were ill because of the radiation. But today it's not as common as maybe a year or 2 years, even 10 years after the bombs first fell.
So when the bombs were dropped essentially over the cities, they did not detonate when they hit the ground, of course. They were detonated above the city. So approximately what was the altitude for the two bombs when they detonated over the cities? And that's
I don't
all
have,
three panelists.
right. I don't have those notes in front of me.
Okay, well, let's move on to another one. Was there any, Operation Downfall looked like it was quite an extensive operation. Was there any part of that the Russians were actually going to participate in?
Well, I can say that in terms of the actual tactics of going in through Downfall, they were not a part of that operational part of the attack. But in terms of coming in, so they were in Manchuria and China, and they would have, their participation would have been geographically in a different area. But,
right. I believe they had not developed the ability, or their strong point was not amphibious warfare. So they would have been, as David was saying, focused in Manchuria.
Yeah, a lot of people, for the army in particular, Manchuria were shocked to hear about the surrender. They had millions of men in uniform with weapons prepared to continue to fight. And they didn't have the same experience of constantly losing as those troops deployed in the Pacific Ocean. However, the means to support those troops, the logistics, the food, the war materiel was quickly coming to an end. What could not be attained in theater in Manchuria was not going to come from any other source. So temporarily, the Japanese were rather in that area in Manchuria were surprised because they seemed so strong, but it was only a temporary condition where they would have rapidly deteriorated without any central command or the means to take care of those people through a logistical chain.
This looks like this will be our final question here. And Joe, you touched on some of this in your presentation, but the question reads, it sounds like the German physicists were actually ahead of us in their atomic research. What happened to prevent their success?
Well, to my understanding, it's because there was a slight miscalculation of how much uranium would actually be needed to create an atomic bomb. So where it was discovered through the Britain's MOD committee that you could refine uranium and use that, and it's a reasonable amount. Like I mentioned earlier, scientists initially thought that you needed a lot more than that. So the Germans believed that was still the case, because of course they weren't privy to that report. So they assumed you still needed a lot more. And they had explored, having a nuclear testing program and flirted with the idea. But because it felt unreasonable to them, because of the amount of uranium they thought they needed. So that was the big reason, is that they just thought it wasn't worth trying to get all of that uranium.
David, Chris, you have anything to add on that question there?
No, I do not.
No.
Oh, I did see one question I'd like to answer if possible, just because I think it's an interesting one to share. The last one, this person asked, why was the untested gun type bomb dropped first instead of the tested implosion bomb? It's a great question. It's because scientists were absolutely certain the gun type was going to work. The plutonium one was a little bit different because it was more theoretical in what they were doing. They knew that because of how the original chain reaction, where you're colliding the two uranium masses, the plutonium bomb was they were less certain about that one. So that's why they knew the gun type was going to work. So they wanted to try the plutonium type implosion.
Well, thank you, Joe. I think that's going to do it for our time here. Again, thank you, Mr. Joe Kent at the National Atomic Testing Museum in beautiful Las Vegas. Once again, Chris McDougal, archivist here, and of course, Dr. David Shields, our Director of Education here at the National Museum of the Pacific War. Folks, we hope you've enjoyed this final webinar in our webinar series. And I'd like to remind everybody that if you are interested in this topic, please make sure you go to our website, pacificwarmuseum.org. We have an annual symposium coming up just about this topic right here, Home Alive in 45, Pivotal Decisions to End World War II. That's going to take place on the 18th and 19th of September. So folks, please make sure you stay active on our website and be sure that you're looking out for other special events to finish up the year 2020. Again, thank you all of us for joining us. And that'll do it for this webinar series here at the National Museum of the Pacific War. Thank you.